Hi everyone, I'm Hoi Lam from the Android machine learning team. And if you want to follow me on Twitter, I'll basically tweet out some of the latest development with Android machine learning. So just follow me on the Twitter handle of Hoitab, Hoitab. Today I'm going to talk about the 4 steps of Android machine learning. So before we kind of really dive into the details, let's take a look at some of the kind of information. First of all, kind of why machine learning at all, and then secondly, why do we do it on device? So what's the difference between kind of machine learning and traditional programming? And if we take the example of activity detection, differentiating between walking, running, biking, you might do something like this, where you pick up one of the features, something called speed, let's say, and then say, hey, if it is less than 4, it is walking. If it is between 4 and 12 kilometers per hour, it is running. And then anything faster than that is biking. But then what happens if you add a new activity like golf? It is not defined by speed, and this means that if you have some code that is based on somewhat unstructured data, it's really hard to make it extensible. So instead of doing what we do in traditional programming, in machine learning, we do something different. So in traditional programming, what we do is we feed in the rules as well as data, and then we get the answer back. In the example that I gave, the rules are related to speed, and the data is basically essentially the speed, and we get the answer of which kind of activity. In machine learning, what we do is we feed in things like accelerometer data, maybe gyroscope data, as well as what we think are the answers. So, it could be running, walking, or golfing, and then it will work out a rule for you. And once the rule is worked out, we're basically going back to the traditional programming way of running, where we feed in the rule that is predefined, and then feed in the data and output the answer. And it will look something like this, where the computer will take in the accelerometer or gyroscope data, and it will generate the rules. And this is something that's easily extensible for unstructured data. And then the second question of why do we want to run this on device? Because ML is great running in the cloud, in all these massive data centers. So why should we do this? I would highlight 3 reasons for this. The first is data privacy. The data stay on your user's device. Second is it works offline. So, when I'm allowed out here in London, then I can go to the London Underground and the functionality will continue to work because it can work offline, is on the device. Last but not least, and this is the thing that I'm most excited about, is that there is no round trip to the server. So you can provide a very live experience and guide the user through the experience. And you don't need to worry about a 500 millisecond kind of round trip between the device and the cloud itself. And today, in the rest of this talk, I will do something different. Instead of focusing on our product line, I'll focus on the journey that you would normally go through when you're developing an Android app with machine learning functionality. So the first one is design, then the second one is finding a model. If you decided that machine learning is the one to go for. Then next we could be building a model. So let's say you can't find a model exactly that you want to customize it, or you want to build your own. We can talk a little bit about that. And last but not least, once you have got the model, how do you actually add it into your Android app? So first of all, machine learning design. The only thing that I want to highlight in this section is something that we've launched last year called a People plus AI Guidebook. We launched it during I/O of 2019, and in it is full of tips and worksheets, in fact, for both you as engineers as well as designers and product managers. I find it the most helpful when you're using this guidebook as part of your design sprint. It will really guide you through the different steps of choosing which way you want to go down in terms of design and what kind of machine learning functionality you will want to build. So check it out and use it during your design sprint. Next, so once you decided that machine learning is for you, what is the easiest way to find to put it all together? And it is, of course, finding a model that is already existing and use it directly. So in this particular section, I will highlight 3 sets of functionality from our product portfolio. The first one is MLKit, the second one is coming from the Android platform, and last but not least, the TensorFlow Hub. So with MLKit, it is a ready-made library that is ready to use, just like any other SDK. You can access the APIs via Java or Kotlin, and there is absolutely no ML expertise required. It's built on top of TF Lite, and it is cross-platform. So I know today is an Android developer conference, but some of you might develop for iOS as well. And you'll be glad to know that all the functionality that I talk about in MLKit can be used on iOS. And since June of this year, all you need to get going is this line in your dependency. So you just need to import it from com.google.mlkit, and you're ready to go. There is no longer the requirement to get a Firebase developer account before you can use it, because all the functionality at the end of the day is on the device. You don't actually need the cloud to use it. And the portfolio offering is actually quite broad. And since the beginning of this year, we've added 2 additional functions. One is digital ink recognition, essentially handwriting recognition. And the second one is pose detection. So trying to detect whether your user is, for example, doing the correct yoga pose or counting how many push-ups that they have done. Pose detection is your friend. Because the portfolio is so large, I will not bore you with every single one of them, but I would like to highlight some of the details related to these 3 APIs. Smart replies, translate, and the handwriting recognition, and also object detection and tracking, just to give you a taste of what is in store. So the first one, smart replies. It provides answers to so many live questions. So in this case, hey, should you take that job at Google? And it will say, no, sure, yeah. Okay, these are really reasonable responses. And the special thing that it does beyond machine learning is to know when to back off. So when there is a sensitive subject like politics or religion, or for example, if someone passed away, you really don't want machine learning to get into the middle of that conversation. So in this case, what the machine learning algorithm learned to do is to say, we will not be providing suggestions. So in this case, as many of you know, it is a contentious topic. Brexit, the exit of the UK from the European Union. In this case, when you ask, hey, what do you think of Brexit? The API will actually reply no answer at all. And this is something that you should think about when you are coding your own machine learning algorithm. Sometimes having no answer is better than actually having an answer. Next, digital ink recognition. This is something that we launched recently. It supports over 300 different languages. And one thing that I want to highlight, which is different compared to recognizing characters or the traditional OCR, the optical character recognition, is that this doesn't just recognize the image, it actually goes through the brush strokes. And the magical thing here is that because it goes through the brush strokes, it knows which characters comes first and which one comes second, which is something that is really tricky to do in traditional OCR, as many of you know. Because if you've got a block of text, sometimes it's difficult for the OCR to decide, hey, this column followed by this column, followed by that column, or even flowing between the different lines, because the algorithm just recognizes the characters kind of individually and in a group as a word. But with digital ink recognition, you do not have that problem at all. And as always, it's run on device and is often on no cost, at no cost. And all the conversation that you put into through this API is safe. None of it is transmitted to Google. Next, I want to talk about object detection and tracking. And in this particular example, I want to highlight how you might use on-device machine learning together with cloud machine learning, both together. So in this particular case, our partner IKEA come up with a solution whereby the customer can point at an object and very quickly find it in their very extensive product portfolio and being able to retrieve the price and the availability from that catalog. So how is it done? The first thing is the camera, of course, capture the image, and it runs through the MLKit object detection and tracking. And at this point, it would do a coarse classification because if you're IKEA, you only really want to focus on home goods. You don't want to picture, capture the jacket that the person may be wearing, from far away. You just want to capture all the home goods that is related to that image. So you can really crop it and filter it based on that. Next, it will send you essentially this white rectangle image over to in this case, the Cloud Vision product search. You can also replace it with any other third-party solution. And what it does is it can then match it up against your own catalog. And as many of you know, if you work in retail, your catalog changes all the time, at least on a seasonal basis, if not by the minute, because you have different availability, you have different pricing. So when you are trying to retrieve those, you might as well kind of do the recognition in the cloud. And also because the model is hosted, then you don't need to send all the updates to your product catalog to the users all the time, saving bandwidth in this case. So this is how you could potentially marry up the live experience that you deliver on device, as well as the cloud experience where you offer up to the minute, essentially inventory or color options that the user might want to select. So this is maybe one way that you can do this. To find out more, you can go to this link, g.co/MLKit, to find out about all the entire portfolio of MLKit. Next, Android platform. So the functionality that I want to highlight is related to speech recognition as well as text-to-speech. And the thing that I want to highlight here is that text-to-speech is really old as an API. So it was actually launched in Android Donut API level 4 10 years ago. But don't worry, we're not using the same model as 10 years ago. These models are continuously updated as part of the system services, so you can always get the latest from Google. And it's the same with speech recognition. We launched it back in Android Folio API level 8. So what I'm trying to say is it should cover pretty much all of your users if you're thinking about using these APIs. And if you want to find out more about the step-to-step process of how to implement it, I would suggest that you go to this video from last year's Google I/O What's New in Machine Learning, where I go through this flow step by step. But one thing that I want to highlight is this. So I'm sure that today a lot of you coming from EMEA speak a number of different languages, and some of you might worry that, hey, Google. And your headquarters in America, would you only speak American English? The answer is no. Actually, we support a very wide variety of languages against this API. So I come from Hong Kong, which is a city of about 7 million inhabitants. We do not speak or as a main language Mandarin, which is the mainstream Chinese language in mainland China, but instead we speak a different language called Cantonese. And in this case, this particular API actually do support this dialect or an alternative language in Hong Kong as well. So please do try it out. Whatever language that you're interested is probably supported by the API. Last but not least, TensorFlow Hub. So TensorFlow Hub is a large repository of TensorFlow model, both from Google as well as the wider research community. And for mobile developer, the thing that you should be interested in is clicking on this button, which is the TensorFlow Lite or TF Lite section. This is a model format and a framework for running machine learning model that's optimized for both mobile as well as Internet of Things devices. So the graph are changed as you basically convert from the main TensorFlow format to TF Lite, and you get that optimization for free. And once you click on that particular button, then you essentially are viewing a filtered view of all the different models that's available on TF Hub. And But at the same time, the way that I access it is actually through the search box at the top, and you basically just type in the kinds of model that you want, and then see whether that is available. I just want to highlight a couple of models that is available today on this site. So CVPR, which is a large industry conference for image processing, this year we launched several large-scale classifiers. So these kind of numbers are previously only possible in cloud-based machine learning model. But our research team have managed to shrink them sufficiently and make them performing enough that actually it can perform live against real images. So for supermarket goods, we can classify between 100,000 different classes. For wine labels, similar, even more, 400,000 different classes. We've also got landmark models for 6 different continents. And for each continent, we have close to 100,000 different landmarks classified. The only health warning here is the model size. So if you look at the US supermarket goods, that's about 40 megabytes in terms of size. For the wine label, that's about 140 megabytes. But going back to earlier about what I said, the fact that they can be run at all on a mobile device and run it in a live environment is something that's really magical. So if you want to check those out, you can go to TF today, and you can also read the Google AI blog related to this large-scale classifier for more detail. So just to sum up, MLKit, where you can access a wide variety of different machine learning functionality through Java/Kotlin APIs, no machine learning expertise required. Similar to Android platform, where you get speech recognition and also text-to-speech for free. And then finally, you have the TensorFlow Hub repository of model, where you can find a lot of model that's optimized for mobile, and the format that you're looking for is TF Lite. So what if all these wide variety of product is just not quite enough for you? What if you want to train your own model? So in this section, I will describe maybe 2 different routes that you might go through. The first one is Firebase ML, and then the second one is the TensorFlow Lite model maker. So with Firebase ML, they have an offering called the Firebase ML Auto ML Vision Edge. It's a rather long name, but what it is a really user-friendly way of training your own image classifier. So what you do is you upload your set of images, and you upload the label against those images. Click on a button, and you might need to wait for an hour also, or some period of time, and then you come back, and you will basically have a TF Lite model ready for your deployment. And when you're doing the training, you can also look at the trade-off between size and speed and accuracy as well. So it is not just the one choice that you have, but you can basically think about the different trade-offs that you want from your model. So that's a very easy to use graphical user interface tooling that you can use from Firebase. Next is TensorFlow Lite Model Maker. So this is something that we've launched during the back end of 2019, and we have continued to improve and add new functionality to it. So when we launch, we have, again, the basic image classification. And in this case, you can also see that here there is a button called Run in Google Colab, where you can just click on that option and start running the particular Colab. It is a framework that's based on Python, and some of you might not have got it set up on your machine in quite the right way. But if you click on Run in Google Colab, you just get a virtual environment, and you will be able to run that training using Google's data center for free. And in my own personal experience, I actually find it to be more performant than my workstation at work. And one of the top reasons for that is because the GPU, the amount of GPU memory that those models have is really top notch. There is a lot of GPU memory, so a lot of the training actually run a lot faster using Colab itself. And The second functionality that I want to highlight is a new one that we've just launched this summer, is question and answer. So this is based on a cutting-edge machine learning model called BERT that we introduced. And what it does is you can provide the model with a passage which contains an answer to the question, and then ask it a question, and the model will be able to work out where that answer is within the repository of answer. So by default, there is a trained model that use a lot of different Wikipedia articles and in their training. But if you have your own set of let's say specialization, an area where you have different knowledge and you want to train this model for your particular domain, you can actually do it through this particular Python script that is published in the model maker. And the training data you need to provide looks something like this. So you essentially provide a passage. Here we call it a paragraph, and then at the bottom you provide a question, and also you provide the answer. And after you have done that, for your own particular domain, then the model that pops out, the TF-like model that pops out, can be more can essentially answer more specialized questions in your own domain. So this is something that is worthwhile trying. So that's the two solutions. One is from Firebase ML, the AutoML Vision Edge, which provides you with a GUI interface to train an image classifier. On the other hand, we have a Python training library that's available on the TensorFlow site, which can help you train a variety of models, including image classification, but also other things like text classification or question and answer. So once you have got the model, how do you integrate it into your Android app? So here we have three solutions that you can potentially look at. The first one is MLKit. Second, the TF task library, the TensorFlow task library. And last but not least, the Android Studio ML model binding. So let me quickly run you through all three of these solutions. So within MLKit, although we provide image labeling and object detection and tracking, a lot of our developers actually say, hey, can we use our own classifier because the ones that you have by default actually doesn't quite serve us? And let me illustrate how that might be the case. So within object detection and tracking, the example that we have earlier, you might have other use cases. So for example, if you're producing a line of clothing, and those clothing looks so different compared to the example that we have, the filtering that we have by default for fashion goods may not pick up on your particular brand of clothing. So in those cases, you might want to train your own classifier so that we pick up on your particular taste or style for fashion goods. That's one. The other one is potentially you just want to classify or you don't want to do the classification in the cloud, and you really want to, and you have a stable kind of set that you want to classify as well. So in those cases, you just want to feed in your own TF-like model. And the new API allows you to do that. So in terms of code, this is how it looks like. In the build.gradle file, instead of just saying object detection, you actually import object detection custom. And that gives you an option of specifying a local model. So here you just specify the TF-like model. In this case, I put it under the SF file path. And you build up the custom object detector option, feeding in that local model. And then last but not least, get an instance of the object detector feeding in that option. And that's all you need. And then after that, it just works the same way as the normal object detector. Way of integrating custom TF model, custom TensorFlow model. The next one is the new offering that we introduced this summer. It is still a little bit of a work in progress, but I really want to highlight it to this wider community. It is a TF-like task library. So off the back, it has 5 different tasks they support, including image classification and object detection, but as well as other functionalities like question and answer. It supports languages such as Java and by default Kotlin, as well as something like C++. However, the drawback here is that at the moment it only supports CPU configuration in a single thread, but the team is actively working on other acceleration options, including multithreading and hardware acceleration. And the last thing, a little bit of a health warning, is that this is available as a nightly build at the moment. So if you're using it in your production app, I strongly advise that you take a cache copy of basically of the nightly build that you're happy with, just in case that in the next version, let's say the API change, or there's something broken in the build, you will not be stuck with that latest build. It really is some of the bleeding edge from the TensorFlow team. So when you're using it, this is what it looks like in terms of both C++ API and the Java API. And here, just want to highlight, it is a similar convention to all the other ML APIs that's easy to use. So you just build a options object, and then you get an instance of the classifier, and then you just use the classifier directly. So this is similar to other API that you might get for image classifier. Another one I want to highlight is the question and answer API. So here, if you have kind of tried any other way of doing ML at all, some of these natural language processing models are really hard to implement. Not because it is difficult, but it is there's a lot of boilerplate to convert the string and using the vocabulary that you might use to train the model to then get into the byte array and feeding it through the TF interpreter. So all that is done for you. Now all you need to do is to put in a context string, which is essentially a paragraph of knowledge or maybe more. And then the second one is the question string, and it will come back with what it thinks are the answer. And last but not least, Android Studio 4.1 ML model binding. So here, actually, the journey started 2 years ago at another droidCon, at droidCon Berlin. So at that droidCon Berlin, I created this particular ML model to say, hey, can you identify whether it is Hoi or not? And it is, and there was kind of funny anecdote about how ML failed and how basically my bias data set, really corrupts that model. So I'm not here to talk about that, but instead this. These are many of the boilerplate code that I needed to use at that point. Because when you look at TF interpreter, which is the way to run TensorFlow model without all the support library before, the input that you need to put in are in byte array. So inevitably, you take an image, then you need to convert it into byte array, and then on the way out, you need to convert the answer back from byte array back to let's say a list or map that your Android app can actually process. This is extremely tedious, and it is very easy to get wrong, as you will see in these real life errors that I get as I try to program that particular app. And we thought, hey, maybe we can do better. So both the TensorFlow team and the Android team came together to produce the ML model binding functionality in Android Studio. So this is what it looks like. When you have your Android project, you just right-click in the module that you want to add the functionality, click New, Other, and then the TensorFlow Lite model option. After that, you'll get a dialog which allow you to specify where the model is. And if you want to use hardware acceleration, then you should take that second box to add the GPU support into your machine learning functionality. After that, you will see this screen. So once the model has been imported, you can see what the model is, the input and output type, which is something that you didn't get before. And this is the magical section where you can essentially copy and paste the code that is needed to implement that particular function. And this section is dynamically generated depending on the signature of the model. So this is something that is super helpful when you are trying to kind of implement TF-Lite functionality. So at the moment, it is still in release candidate, but we're hoping that soon Android Studio will be going into production. And at that point, you can download it here. Otherwise, you just need to add a preview at the end of this particular URL to try it out today. So those are the three solutions: MLKit, TensorFlow Task Library, as well as the ML model binding. So you might say, wait, a lot of it seems overlapping, and which one should I choose? And you'll be correct. Actually, there is a lot of different options that you can choose. So here I will highlight three high-level considerations that you might want to think about, and also two much more subtle differences between different ways that you can implement similar functionalities. So the first high-level consideration is production readiness. So if I think about from the left-hand side to the right-hand side, on the left-hand side, we have the most production-ready solutions. TF-Lite interpreter have been ran for a number of years now, essentially from the beginning of TF-Lite. And then also in addition, MLKit has been in existence for the last 2 years. So those are very mature solutions that I feel very comfortable basically putting into production. On the other side, we have the ML model binding that is just about coming into production. So we have gone through the testing in Canary and Beta. So I think it is almost there. And then on the other side, you get the bleeding edge kind of nightly build of TF-Lite Task Library. So that's kind of one consideration that you might have, production readiness. The second one is around C++ support. So if you're coding in native, then actually the only option, I'm afraid, is the TF-Lite Task Library or the TF-Lite interpreter, because all the other solutions are not supported in C++. And then finally, when you're thinking about hardware acceleration, then the option that you should choose is ML model binding or the TF-Lite interpreter. So those are the solutions where you can switch on the GPU acceleration or using NN API, or in other cases, kind of use multi-threading CPU models. So those options exist in ML model binding and TF-Lite interpreter. So those are the three high-level considerations. If we drill a little bit deeper into the more subtle differences between different ML models, there are two things I want to highlight. The first scenario is something that I get asked all the time, because we have things that are called image classification. Essentially, you take the whole image and then you say, hey, what does that image stand for, or what is in that image? And then on the other hand, you have object detection, where you essentially try to shrink that to a smaller area to the overall image and say what it is. So when should you use each one? Because each one of them give you a category and also a probability kind of coming back. It really doesn't seem like all that different. So if we take a step back, with image classification, you're using the entire image for classification. So it's just really suitable for things like landmark or scene. If you try to determine whether this is an urban area versus like a forest, you can use image classification, and that's perfect. However, if you are thinking about another use case where you have, say, different brands of milk and carton right next to each other on a supermarket shelf, what you want to do is to use object detection and tracking so that the user will essentially say, hey, this is the carton of milk that I want to recognize, not the one standing right next to it. And that will basically help you increase your detection accuracy without actually changing your model itself by localizing the area of interest in the implementation. So think about it. On the one side, you have scenes and landscape. On the other side, you have essentially, let's say a product shelf where the different objects are very densely populated. So that's one way to differentiate between these two functionality. The second way to look at this is around object detection. So there are two ways to implement object detection. One is the MLKit way of essentially creating a generic object detector, trying to focus on, in this case, the white rectangle. And then it does two things after that. One is to feed that white rectangle into a custom image classifier to customize it once. And then it actually uses a very low-powered image tracker. So that tracker actually does not know what that object is, but it just kind of follows that around. And as you can see in the white rectangle, the percentages above it, that detection percentage actually do not change from frame to frame because it only did the classification once, and that classification stays with that object for the duration of the tracking. On the other hand, you have what we call single-shot detectors. Essentially, this model not only detects the class of the object, but also where it is within the image. So as you can see, I don't know if this is very clear within the live stream, is that number changes from frame to frame. And also sometimes you will see the keyboard, the red kind of rectangle disappear for a couple of frames and it comes back. That's because it tried to use every frame and try to detect what object there is within that. And these two implementations might not look all that different if you're running on a relatively powerful device. So in this case, I ran both on a Pixel 3 phone. So it's a flagship phone that is not that old. And in the two cases, it doesn't look all that different. But if you are thinking about deploying it on a wider variety of Android devices, some may be quite old or low powered, then I would strongly suggest that you go down the route of the ML kit implementation, because the tracking algorithm is a lot less power intensive than actually classifying the objects on every single frame. So that should give you a much smoother result than the single-shot detector on a wider variety of devices. On the other hand, if your use case is more to do with, hey, here's an image, can you help me with the hashtag? Then single-shot detector is perfectly fine because you're essentially operating on an asynchronous basis, and you don't really need kind of frame-by-frame kind of detection as such. Then in that case, it may be not that different. Also, if your app is aiming for high performance Android phones, again maybe the two scenario might not look all that different. So just to sum up, there are some high level considerations such as whether you use C++ or not, and also some more subtle consideration around how wide you want the functionality to be used, or different types of image classification that you might have. So at this stage, actually, it is not done after you've implemented the TF model. The next stage that you need to go through is actually going back to ML design again. And this is something that might surprise a lot of you, because with traditional programming, once you have done, once you have tested, you just go, hey, my job is done. Now let's ship. But in this case, quite often, even when you are having the best model, you're still saying that, hey, I reached 90+% accuracy. So what should you do with the 10% where it is inaccurate? That actually drives a lot in terms of how the user will interact with your app. And to illustrate this point, I just want to introduce to you this app, which is Learning to Read. It is an app that is available to children, in this case, aiming at children to teach them how to read different languages. And in this particular case, if we think about precision and recall, this is what it means. Precision is biasing towards getting less false positives. And what this means is some of the correct pronunciation, or these happy faces outside the green circle, will be marked as incorrect if you're optimizing for high precision. On the other hand, if you optimize for high recall, then some of these unhappy faces will be within the green circle, meaning that some of the incorrect pronunciation will be marked as correct. So in this case, which one should you choose? Having very high standards, or maybe having a more forgiving kind of ML algorithm? In this case, the team actually choose the latter. So if you stand back and think about it, if you're teaching a child how to pronounce something, you want to be as encouraging as possible. So in this case, we say, hey, actually high recall is fine, and after user testing, and that's the version that we launch with. And in your particular scenario, you might have a slightly different take on the whole thing. So just to sum up, the 4 different stages of machine learning, from design to finding a model, to building a model, to implementing, and then after implementing, actually going back to design to see how real-world users interact with your machine learning functionality. And if you want to read up on a lot of the topics that we talked about, I suggest that you follow through this link, Google essentially /MLWrap, and here you'll find a bunch of links to various product offering that we have within the portfolio. And with that, I think we may be able to take 1 or 2 questions. Thank you. Okay, so let's have a look. What are the questions that we have? Okay, so is it possible to run simpler machine learning model like random forest, etc., like those patterns that you've shown? Do you have any tips for that? The answer is absolutely yes. So you can run less complicated model. You just need to translate it into a TF-like format, or that's one of the way to run those models. Another way is if you have a really simple, let's say linear regression, you can even just pick up on the coefficients and just use those as maybe not quite hard-coded, but as color configurations within your app. In those cases, then your app is super updatable because all you need to do is to do some remote config, and then the coefficients themselves can change. So it really depends on how many different parameters that you have. If you have a lot, then it may be worthwhile using the TF-like model. But if you only have a handful of parameters, I would suggest that you just pick out the coefficient and just have those as remote configuration parameters. Cool. So what source would you recommend regarding learning and understanding the algorithm behind ML? Where can you find guidance, reasoning about and building custom models? Actually, one of my colleagues, Lawrence Maroney, you should follow him on Twitter. He is, I don't know whether his book has been launched yet, but he's got a book that is coming out that will basically go through the basic understanding of machine learning. And also his way of teaching is very much geared towards developers, so not machine learning professionals, but rather from a mobile developer or everyday developer trying to kind of get a head start on machine learning. So I highly recommend his content. There is also a course on Coursera that is taught by him and Andrew Ng. So again, strongly recommend that. So these APIs can be used, some model generated with Python. Yes, so the APIs that I have highlighted can be used for models that's generated with Python. So basically, at the end of your training step, you then run a TF-like converter, which will then output a TF-like model, and that's the file that you should import into your Android app, and you can run it from there. Okay, so very last question. Does library helps with language recognition, which language and which language direction? So there is, in MLKit, there is actually a language ID function that is really, really small. I think we're talking about, I can't quite remember, but it's the low hundreds of kilobytes where you can feed it a string and then it will detect what language it is. So yeah, please give it a try. And for more information, my DM is open on Twitter on Hoitab, HOITAB. So just ping me a message and I will be able to take more questions there. Thank you.